Hello students. Here we are going to solve previous year JEE questions on the topic quadratic equations. With each question I would be discussing the corresponding concept in detail, so you have revision of concept as well. To get a better understanding of the sums, what I would suggest is you just pause each sum, try to solve and then look at the solution. Let's get started. Okay, students, first question says if alpha is not equal to beta with alpha square, this should be alpha square, this is equal to 5 alpha minus 3 and beta square equal to 5 beta minus 3. Then the equation having alpha upon beta and beta upon alpha as its roots. So we need to find an equation which has these roots, alpha upon beta and beta upon alpha. Okay. Now let's look at these conditions. Alpha square is 5 alpha minus 3 and beta square is 5 beta minus 3. Now looking at these two equations, we can identify that it looks like one quadratic equation, x square equal to 5x minus 3 having two roots alpha and beta. Right, so roots must satisfy the equation, so we get first when we put alpha in the equation and second when we put beta. All right, so now we have a quadratic equation x square minus 5x plus 3 equal to 0 having roots alpha and beta. So alpha plus beta would be 5 and alpha into beta, that is c by a, would be 3. Fine. Now we need a quadratic equation. Required quadratic equation has roots. Required quadratic equation has roots alpha upon beta and beta upon alpha. Right? So required quadratic equation will look like x square minus sum of roots, right, times x plus product of roots. Product of roots is just 1 equal to 0. So to get the answer we need this quantity alpha upon beta plus beta upon alpha, right, which becomes x square minus alpha square plus beta square upon alpha into beta times x plus 1 equal to 0. So alpha into beta we know it is having value 3. We need alpha square plus beta square. Now alpha square plus beta square can be written as alpha plus beta the whole square minus 2 alpha beta, right? So from the obtained values it is 25 minus 6, which is 19. So we get required quadratic as x square minus 19 upon 3x plus 1 equal to 0. This becomes 3x square when we multiply by 3 minus 19x plus 3 equal to 0. So correct answer is option B. Okay students, question 2 says the number of real roots of the equation 3 raised to 2x square minus 7x plus 7 equal to 9 is. Now 3 raised to 2x square minus 7x plus 7 equal to 9 can be written as 3 square, right? So on comparing indices we get 2x square minus 7x plus 7 is equal to 2, right? Now this can be written as 2x square minus 7x plus 5 is equal to 0. For this quadratic equation, let's find out discriminant d, that is b square minus 4ac. This is 49 minus 4 times 2 into 5. This is 49 minus 40, which is 9. So discriminant of this quadratic equation is greater than 0. So quadratic equation has two real and distinct roots, right? So the correct answer is option B. Question 3 says, if sum of the roots of the quadratic equation ax square plus bx plus c equal to 0 is equal to sum of the squares of their reciprocals. Okay, So as per the given conditions, sum of roots alpha plus beta is equal to sum of squares of reciprocals. So squares of reciprocals 1 upon alpha squares plus 1 upon beta square. So this is given condition. This becomes alpha plus beta is equal to alpha square plus beta square upon alpha square beta square. Now alpha and beta are roots of this equation, right? So alpha and beta are roots of this equation. So we can write alpha plus beta as minus b by a, alpha into beta as c by a. We can put these values, and alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. This becomes alpha plus beta whole square, that is b square by a square minus 2c by a. So when we substitute these values, this will become b square minus 2ac upon a square. So now this condition will become alpha plus beta, that is minus b by a is equal to alpha square plus beta square, that is b square minus 2ac upon a square. In the denominator we have c square by a square. So a square we can cancel, and now we get minus b by a is equal to b square minus 2ac upon c square. On cross multiplying we get minus bc square is ab square minus 2a square c. Now if we shift the terms, I will take 2a square c on one side equal to ab square plus bc square. On dividing both sides by abc, we get 2a square c upon abc is ab square upon abc plus bc square upon abc. So this becomes AACC will get cancelled on left hand side. It is 2a by b, right, is equal to AB will get cancelled in the first term. It is b by c plus c by a. Alright. So this means we can say b by c, a by b and c by a are in AB, because double of middle term is first plus third. Now what question is asking us is a by c. Look at this, students. A by c, b by a, c by b. A by c, b by a, c by b. So it is reciprocal. If these three terms are in AP, then their reciprocals will be in HP. So correct answer is harmonic progression. Okay, question 4, student says the number of real solutions of the equation x square minus 3 mod of x plus 2 equal to 0 is. So here we can use one property that uh, x square can be written as mod of x the whole square. Okay, so the given quadratic equation x square minus 3 mod of x plus 2 equal to 0 can be written as mod of x the whole square minus 3 mod of x plus 2 equal to 0. Now assuming mod of x as a variable, let's say y, we can factorize this equation and it will become mod of x minus 1 into mod of x minus 2 is equal to 0. So mod of x can have value 1 or mod of x can have value 2. So x can have value plus minus 1 or x can have value plus minus 2. So number of real solutions are 4. Okay, question 5 says the value of a for which one root of the quadratic equation a square minus 5a plus 3 times x square plus 3a minus 1 into x plus 2 equal to 0 is twice as large as the other. So given is one root is twice the other. So let's say beta is twice the alpha. Okay. In a given equation, alpha plus beta is minus b by a. Okay. So if you put beta as 2 alpha, we get 3 alpha is equal to minus of 3a minus 1 divided by a square minus 5a plus 3. Similarly, alpha into beta is 2 upon a square minus 5a plus 3. This will become, when we put beta as 2 alpha, it will become 2 alpha square equals to this quantity. So we can write alpha square as 1 upon a square minus 5a plus 3. Now alpha value we can obtain from this equation, that is this ratio into 1 by 3. So alpha square would be 1 by 9 into 3a minus 1 the whole square divided by a square minus 5a plus 3 the whole square. RHS is 1 upon a square minus 5a plus 3. So the good thing happening here is we can cancel this bracket, and then if we shift the denominator on the other side, we get 9a square minus 6a plus 1 equals this denominator on the other side 9a square minus 5a plus 3. So 9a square will get cancelled here. Okay. So minus 6a plus 1 is minus 45a plus 27. 45a when we shift on the left hand side, we get 39a is equal to 26. So a is equal to 26 upon 39, that is 13 2s are 13 3s are 2 by 3. So a is the answer.